Welcome to lesson 14. This is the last lesson. Prologue. A large band of stars, gas and dust particles held together by gravitational force is called a galaxy. It consists of billions of stars. Some galaxies emit a comparatively small amount of radio radiations compared to total radiations. They are called normal galaxies. A galaxy. Our galaxy Milky Way is a normal galaxy, spiral in shape. The nearest galaxy to us, known as Andromeda galaxy, is also a normal galaxy. It is at a distance of 2 into 10 power 6 light year. Some galaxies are found to emit millions of times more radio waves compared to normal galaxies. They are called the radio galaxies. Video is given here. Please watch it.
Did you know that you can see some of the most interesting deep space objects with nothing more powerful than a pair of binoculars? In this video, I'll show you how to locate one of these objects, a galaxy. You probably know that a galaxy is a massive system of stars, planets, and dust bound together in space by gravity. We live in a galaxy. If you have ever seen the Milky Way on a clear night, you have seen our galaxy. This soft glow is created by billions of stars. We call our galaxy the Milky Way galaxy. Astronomers classify our galaxy as a spiral galaxy. If we could view it from out in space, it might look like this. It turns out that we are not alone. Astronomers have determined that there are billions of other galaxies in the universe. These other galaxies exist at tremendous distances from Earth. To see most of these, you would need a powerful telescope, but there is at least one galaxy close enough to Earth that it can be viewed with nothing more powerful than an ordinary pair of binoculars. This is the Andromeda Galaxy. Astronomers refer to this galaxy as M31. Here's how you find it. If you live in the Northern Hemisphere, M31 is ideally located for viewing from August through February. To find this deep space object, you need to be able to find and recognize two constellations, Cassiopeia and Pegasus. Cassiopeia, from Greek mythology, represents Queen Cassiopeia. The constellation forms a distinct asymmetrical W shape with 5 bright stars. Once you have located Cassiopeia, use these 3 stars as a pointer. The Andromeda Galaxy is located about 3 pointer lengths away. Browse this area with your binoculars. Andromeda looks like a faint glowing cloud. Another method for locating this galaxy is to use the constellation Pegasus, the flying horse from Greek mythology. The dominant feature of Pegasus is a large square created by 4 bright stars. Extending from one corner of Pegasus, you will find a double trail of dimmer stars. The Andromeda Galaxy is located beside these 2 stars in the center. If you focus your binoculars on the first star, move to the next star, and then move the same distance again, M31 should appear, a faint glowing cloud. If you have good viewing conditions with no light pollution, you may be able to see that the glow extends over a large area. I use 8x40 binoculars with a field of view of 7.5 degrees. This is the size that M31 appears in these binoculars. Viewed through a powerful telescope, it looks like this. The key to finding M31 is learning to recognize and find its adjacent constellations. The relative positions of Cassiopeia, Pegasus, and M31 never change, but their position in the sky does, appearing low above the east horizon in late August evenings and slowly moving to the west horizon by January. There are a number of computer programs available to help you locate objects in space. I use Starry Night. Now that we have located M31, the Andromeda Galaxy, let's talk about what we are seeing. Through binoculars, the image is subtle, but how exciting to know that you are looking at a galaxy, billions of stars bound by gravity sitting 2.5 million light years from Earth. A light year is the distance that light travels in 1 year. This means that the light from M31 that enters your binoculars and ends its journey on the retina of your eye has been traveling through space for 2.5 million years. When you look at objects in space, you are not seeing these objects as they are now, but as they were when the light you are receiving left on its journey through space. If you are successful at finding M31, the image you are seeing was created 2.5 million years ago. When you look into space, you are looking back in time. Powerful telescopes like the Hubble Space Telescope are capable of capturing images from the beginning, images that reach back in time and reveal the evolution of our universe. You don't need a powerful telescope to find and view interesting objects in space. A clear night sky, a pair of binoculars, and being able to recognize some constellations are all you need. For more science and technology videos, visit our website, hylaroad.com. Follow the videos link.
Next topic is Milky Way galaxy. Milky Way looks like a stream of milk across the sky. The Milky Way galaxy, it has some important features. It has some areas. One is shape and size, second one is interstellar matter, third one is clusters, fourth one is rotation, fifth one is mass. Let us see one by one. One is shape and size. Milky Way is thick at center and thin at edge. Diameter is 10 power 5 light year. Thickness of Milky Way varies from 5000 light years at center to 1000 light years at position of Sun and to 500 light years at the edges. The Sun is at a distance of 27,000 light years from the galactic center. You can see the picture is given here, by which you will come to know more clarity. Second one is interstellar matter. It is filled with dust and gases. It is found about 90% of matter is in the form of hydrogen. Third one is clusters. Group of stars held by mutual gravitational force in the galaxy are called star clusters. It moves as a whole in the galaxy. A group of 100 to 1000 stars is called galactic cluster. A group of about 10,000 stars is called globular cluster. Fourth one is rotation. The galaxy is rotating about an axis passing through its center. All the stars revolve around the center and complete one revolution in about 300 million years. Sun is one of the star revolves around the center with a velocity of 250 km per second and its period of revolution is about 220 million years. Fifth one is mass. Mass of Milky Way is estimated to be 3 into 10 power 41 kilogram. Video is given here. Please watch it. Origin of the universe. In order to explain the origin of universe, there are a lot of theories were formulated. In this lesson, only three theories were given. One is Big Bang theory, second one is pulsating theory, third one is steady state theory. Let us see one by one. Number 1. Big Bang theory. All matter in the universe was concentrated as a single extremely dense and hot fireball. An explosion occurred about 20 billion years ago and matter was broken into pieces, thrown off in all directions in the form of galaxies. Due to continuous movement, more and more galaxies will go beyond boundary and will be lost. Consequently, the number of galaxies per unit volume will go on decreasing and ultimately we will have an empty universe. Video is given here. Please watch it.
As our nebula began to collapse under its own gravity and spin faster, a dense clump of matter formed in the center. It's called a protostar. At first, its heat was due to friction, but when the clump reached 18 million degrees Fahrenheit, nuclear fusion kicked in. 4.5 billion years ago, our star was born. Hydrogen atoms fuse together to form helium, and in the process, release photons. It's the first light made by our sun, and it will keep on shining for 4 billion years. A vast nuclear furnace nearly 1 million miles across. From a distance, this process seems almost peaceful, with the sun's power gently radiating out into the early solar system.
There was all sorts of activity going on. Things were changing rapidly, violence, explosions, intense radiation. We had a pretty spectacular origin, I think.
Recent research suggests the solar system's birth was far from peaceful. Our sun may in fact have been born out of one of the most violent events in the cosmos: the explosive death of another star. And even before that, it seems there was an explosion so huge that it created an entire universe. The Big Bang. No one knows what caused it, but we think that the Bang created space, time, and all the matter in the universe. Yet for astrophysicists, such as Professor Stan Woosley, there's a puzzle. The Big Bang produced almost none of the 88 naturally occurring chemical elements.
When we look around, we don't just see hydrogen and helium. We see planets and people, and we're made out of carbon and oxygen, and planets are made out of iron and silicon. And that didn't all come from the Big Bang. It had to come from somewhere else.
Here on Earth, we have learned how to create new elements for ourselves. Nuclear technology. The same thing happens inside stars. Hydrogen and helium from the Big Bang fuse to form heavier elements. And if the star is big enough, at the end of its life, it does something spectacular. It explodes.
The energy of a supernova explosion is essentially equal to all of the energy that the sun will put out in its 10 billion year lifetime.
Second theory is pulsating theory. Total mass of universe is more than a certain value. The expression of galaxies would be stopped by the gravitational pull. Then the universe may again contract. After it has contracted to a certain critical size, an explosion again occurs. Expansion and contraction repeat after every 8 billion years. Thus, we may have alternate expansion and contraction, giving rise to a pulsating universe. Third theory is steady state theory. New galaxies are continuously created out of empty space to fill up the gap caused by galaxies which escape from the observable part of universe. Universe has always appeared as it does today, and rate of expansion has been same in the past and will remain the same in future. So a steady state has been achieved so that total number of galaxies in the universe remains constant. Video is given here. Please watch it.
Science and religion have butted heads since the dawn of time. The Big Bang Theory is no exception. Before the 20th century, there was no general consensus on whether the universe had a beginning or not. Some people believed in the claims of the Bible that God created the universe. Others looked at the beauty of the night sky and simply believed that it was always there. It was only until the beginning of the 20th century when two scientific theories emerged: the Big Bang Theory and the steady-state theory. The Big Bang Theory states that the universe had a beginning and is not eternal. On the other hand, the steady-state theory says that the universe does not have a beginning and is eternal. In 1916, Albert Einstein published The Theory of Relativity, which not only gained him international recognition and success, but also proved that the universe had a beginning. His equation could predict how fast galaxies were moving apart and therefore proved that the universe was expanding. However, Einstein did not like the idea that the universe had a beginning and changed his equation by adding a cosmological constant to make his theory of relativity support the steady-state theory that the universe is eternal. In 1920, Belgian cosmologist and Roman Catholic priest Georges Lemaitre proved that Einstein's cosmological constant was a mistake. He predicted that if the Big Bang occurred, it would release cosmic microwave radiation that should still be in the universe today. Cosmic microwave radiation is the oldest electromagnetic radiation in the universe that the hypothesized Big Bang produced in its early moments. However, many astrophysicists were skeptical and angered by Lemaitre's proposal for two reasons. First, he lacked empirical evidence of the detection of cosmic background radiation. Secondly, the astrophysicists felt like he had a secret agenda. Being a Roman Catholic priest, Lemaitre could be trying to push the Big Bang theory so that it would line up with the biblical creation account that God created the universe from a single point in time. The astrophysicists did not want religion mixing in with science. Though Lemaitre faced much opposition, in 1964, scientists eventually detected the cosmic microwave radiation that he had predicted. To this day, cosmic microwave radiation remains as the strongest evidence to support the Big Bang theory. Whether it may be for science or for supporting his faith, Lemaitre has still left a legacy as one of the founders to a widely accepted theory today. Nevertheless, as history has shown us repeatedly, theories come and go, and over time they are either disproven or strengthened. So far, the Big Bang theory has been tested very thoroughly, with each test reconfirming its validity. Unlike the steady-state theory, which has cracked under several observational tests that showed its flaws.
In addition to that, points to remember is given. Some of the points given, please go through it, followed by evaluation part is given. Some of the questions were asked, please answer it. Thank you. Dear students, all the 14 lessons have completed. Thanks for your kind cooperation. I hope this is very useful to you people. Once again, thank you one and all.